Example on standard deviation calculation. So we are having a set of data, it's 11 data, and here are the measurement. He's asking us to calculate the standard deviation for the measurement set given below. So we need to calculate the standard deviation of the data given here. Here is the answer of the example given in the previous slide, where the example is asking us to calculate the standard deviation. This is the formula used for that. Of course, I did this example, or I answered this example using Excel. It's much easier to use Excel to deal with this kind of cases. So first of all, we put the data here. These are the data which the measurement, the result of measurement. Then the mean, which x prime calculated here. This is x prime. Here is x prime. So now we are going to look at this value, which is the deviation. The deviation is calculated here, where it's equal to 398 minus 409. I mean, from here and here, the difference between them is coming to this point. This value and this value, the difference between them comes here. This value and this value, the difference between comes here, and so on. Then we square the whole thing. We square them, as you see here. Let me just erase it to make it clearer for you. After that, as I said, I square them. So here you will find the square, 11 minus 11 square equal to 121, 11, 121, and so on. That's the square of the deviation, or d square. Then after that, we will find their total. The total is equal to 1370, the total, as you see, the summation. Then we divide it by n minus 1. Remember, n is the number of data. So when n minus 1, the data is 11. We are having 11 data. 1, 2, 3, 4. They are 11 data. So 11 minus 1 equal to 10. So we divide the total over 10 equal to 137. And finally, we put them under root square. So the square root of 137 or 137 is equal to 11.7, which the standard deviation. So the standard deviation is calculated as 11.705. You can calculate it manually, or you can calculate it by Excel, but if you want my advice, please practice it manually. Another example here, consider the table which lists 30 measurements. We are having here 30 measurements of the mass M. So the measurement for the mass M of a sample of some unknown material. Calculate the measured value in terms of magnitude and uncertainty. Look here, he wants to get the value, the actual value, or what we call it, the true value, with uncertainty. Here we are not putting this example for the purpose of calculating a standard deviation. No, we want to use it for measurement. Remember that the true value is to be obtained by the mean of the data. The 30 data, we will add them and divide them by 30 to get the mean, which considered as the true value. And the uncertainty is to be the standard deviation of the data. That's what will be seen in the next slide. So in the answer of the question, we have 30 different data, 30 different measurements for the mass, and we need to calculate the true value with the uncertainty. Of course, when we talk about the true value here means the average. So in calculating the average is equal to the total of the whole data divided by the number of data gives 1.1 kilogram. So that's considered as the true value. The average is the true value. And we will calculate the standard deviation following the same style as before. So by calculating the standard deviation, it's equal to 0.05 kilogram, which allowing us to express our data as the mass is equal to 1.1 plus minus 0.05 kilogram. So that's how we can express the measurement. It's 1.1 kilogram plus minus 0.05 kilogram. Keep in your mind, sometimes we are expressing the uncertainty as value, or sometimes we express it as a percentage of the actual value. Static characteristics of instrument. In the static characteristics of instrument, actually, this is some characteristics help us to select the right instrument for measurement. So when this is helping me to select the right instrument. One of the elements which to be kept in our mind when we are selecting the instrument is the tolerance. It's talking about the accuracy. Tolerance means, or it's related to accuracy, which telling us about the maximum error. With the tolerance, I can know the maximum error that expected out of the device. Here, it means when I want to go for certain device to do certain measurement, I have to consider the tolerance as a one of the parameter. So the tolerance means what? Means what is the maximum and the minimum error expected out of this device. Keep in your mind that always we are looking for measurement with minimum error. That's why we need to consider the characteristics of the instrument. Let us check this example, which hopefully will make us clear about tolerance. So he's saying here, if you read the question, you will find that the question is talking about a packet which having a resistors of 1000 ohm. It's many resistors inside, each of them expected to be 1000 ohm. I mean, what's written on the packet is the resistor value is 1000 ohm. What is the expected minimum value and maximum value out of the packet? So to calculate it, the 5%, we will take it out of the 1000, is going to give me 950. And the 5%, we will add it to the 1000, we will get 1050. That means the smallest value can be found in the packet is 950 ohm, and the highest value is 1050. Another element in the characteristics of instrument is the range or span. When we are going for certain instrument, I need to evaluate its range. I mean, what is the range of that span? Because if you notice, the range is an important parameter in evaluating error or in deciding on the error or uncertainty or many other parameters. What is the range of span? It's simply the smallest, the highest value minus the smallest value. The highest value minus the smallest value. So if we have an instrument, let's look at this example. In this example, in part A, he's saying we are having instrument with a range of from 0 to 150 Fahrenheit. What is its span? It's 150 minus 0, which equal to 150 Fahrenheit. How about in example number B? How about if the range is start from minus 20 up to 200 Fahrenheit? In that instrument, we can find the range as 200 minus 20 equal to 220 Fahrenheit. Same thing if the range is 20 to 150 psi, so we can calculate the span as 150 minus 20, which equal to 130 psi. That's what to be kept in our mind. Of course, we are very much caring about the span because we are supposed to calculate the range or the span of the instrument which is suitable for our measurement. Linearity is how linear the device in its measurement. What does it mean here? It means if I want to look at accurate measurement, I mean accurate or ideal kind of measurement, it's the red color. It's linear, very linear. When you look at the actual measurement of certain instrument, let's say it's the green one. So the green one is very close to the linear. That means the result or the measurement or the device considered linear. The device considered or the linearity of the device is very good. Other device, to understand it better, other device, when we do it, and let's say it's not good kind, when we measure the or do the measurement over a certain duration, maybe we are going to get this kind of measurement. That's far. If you notice, it's far off linear. So the linearity is bad. Linearity is not good. Always we look for linearity, a good linearity, which means the data taken over a certain duration to be in a straight line. Sensitivity of measurement is also an important parameter. It's how sensitive is the device to the change of the measurement. How sensitive the device to the change of measurement. What does it mean here? If simply I want to measure the temperature, let's say I'm measuring the temperature. This is a device, or this is the sensor which measuring the temperature, or the measuring instrument, let's say. If the temperature here is change from value to value, means from 10 to 20 degrees Celsius, will the output, or will the device, the meter, notice this change or not? So here is the idea of sensitivity, is how sensitive the device to the change of the input. So if I want to put it mathematically, sensitivity is the change of output. Let me just erase this. Sensitivity consider as the change of the output over the change of the input. In my device here just now, in my example earlier, my output is the reading and my input is the temperature. Let us see a mathematical example. Hopefully it will make us more clear about sensitivity. Example here, the following resistance value of platinum resistor thermometer were measured at a range of temperatures. Determine the measurement sensitivity of instrument in ohms per degree Celsius. He wanted to say here that when I measure the resistance, if the temperature is 200 degrees Celsius, the resistance found to be 307 ohm. If the temperature 230, the resistance found to be 314 ohm, and so on. So what is the sensitivity? Here we can calculate the sensitivity, the change of output over the change of input, which means, notice the data given in the previous slide, you will find if the change of the resistance from 307 to 314, this is the change in the table of the previous slide, that the resistance change from 307 to 314. So we will take 314 minus 307. That's going to cause different on the temperature, which 200 to 230, which means we can make it as 230 minus 200. So it's equal to 7 over 30, which is equal to 0.23 ohm per degree Celsius. So that's the meaning of sensitivity, how the change, or it's a value which telling me about the change of the resistance, the change of the output to the change of input, how the output will change as the input change. Other element we need to think of while thinking of getting instrument for measurement is the threshold. Threshold is the value where the device is start to show respond to it. To understand it better, let us say we want to measure the temperature of certain liquid. Here we are putting a source of heat, and the temperature is measured by certain device. Let me change the color. This is the device. Here is the measurement. So let's say the temperature is increasing to, for example, 20, 21, 22, 23, 24, 25 degrees Celsius. At 25 degrees Celsius, the device starts to show 25. Before that, device is not showing anything. That means the threshold of the device is at 25. It's not going to show any response to any value below threshold. Below threshold, it's not going to show any response. At the threshold, the device will start to show response. That's the meaning of threshold. So that's all for the for module number 1, week number 3. I hope you are clear about this module. In the next week, hopefully, we are going to start module number 2. I hope you are clear about this module. Still, we are going to be in touch if you have any question. In the discussion session, you can ask, or in the tutorial session, you can ask. I wish you all the best. Thank you.